Alright, so our last skill that we're going to address is putting this all together to graph a physical rational function. And if you like puzzles, you'll like this. Because we've got a lot of individual characteristics, and by themselves, they're not bad, right? It's not hard to find a vertical asymptote. It's not hard to find a horizontal. We've seen intercepts in the past, so it's not hard to find those. The tricky part is going to be connecting all of our facts and being able to create a continuous picture that matches, right? So let's go through sort of what one would do first versus second versus third. So our first step is to find the X intercepts. And I'm putting an S there because there may be more than one. And to do that, we're going to, remember it's something comma 0. And there may be several of them. The hint I'm going to give you is that if we're looking at a fraction, you want to look at the numerator. Setting the numerator equal to 0 will actually tell us the x-intercept. After we find the x-intercept, we want to find the y-intercept. And we're going to plug 0 in for x at that point. Now, if there is one, there's only going to be one y-intercept. Then we want to identify the domain. And this is before reducing it. We'll express that in interval notation. After we find the domain, then we want to identify any holes and any VAs. Let's see, so vertical asymptote and any holes. Then we're going to find any horizontal asymptotes. And any points where it crosses the HA. And then we're going to plot points to determine the shape of the graph and connect any points with a smooth and continuous curve approaching the asymptotes. And I'm going to sort of emphasize what we mean by this chart here in a moment. Sort of write this down. I put parentheses there. So we're going to make a sign chart, kind of back when we looked at inequalities at some point. And we're going to identify any intercepts and any vertical asymptotes. And again, we'll kind of map that out as we see this. Okay, so let's start. Let's just jump in here and get started. So to find our x-intercept, we have f of x equals 3x over x minus 1. I'm going to look at my numerator, set that equal to 0, and solve. So 3x equals 0 means x is 0. So I know there's an x-intercept at 0, 0. The y-intercept, I'm going to evaluate it at 0. So 3 times 0 over 0 minus 1. That turns out to also be 0. So I know it crosses at the origin. Domain, looking at the fraction, I'll figure out where that's not equal to 0, which obviously is at 1. So I want to kick 1 out of my domain. All right, VA. VA, I'm going to look at the denominator. And the same number that I kick out of the domain is going to be my VA. Unless it was reducible, in which case I want to reduce first and identify from there. There are no holes, so I don't have to worry about that. HA. Is this particular rational top heavy, bottom heavy, or same? So you're going to notice you got 3x and x. Both have the same exponent for the leading term. So it's what we call the same case. So it's going to be a ratio of the leading coefficients. So in this case 3 over 1, or y equals 3. And then I'm going to look and see, is there a point where it actually crosses the HA? So I'm going to set 3 equal to 3x over x minus 1 and then try to solve. I notice that I can multiply both sides by x minus 1. if I can write that. Okay, so that gives me 3 times x minus 1 equals 3x. And when I distribute, I get what, 3x minus 3 equals 3x. And interestingly enough, when I try to get the 3x's together, I get negative 3 equals 0. Okay, so that tells me that it does not cross. Okay. All right, so let's kind of come back up here and let's see what do I know and what do I need to know. So first step I'm going to say is let's plot any asymptotes and then plot any points. We're going to asymptotes and points first, and then we'll look at the chart. Okay, so let's see, I got an asymptote at x equals 1. That's a vertical asymptote. So I'm going to come over here and there's my VA at x equals 1. I've got an HA at y equals 3. So right there. Okay. Then I have an ordered pair. So I know it crosses at the origin. Okay. So the question is, now what? Well, there's a couple of things that I know are going to happen here. And part of this, maybe we just want to experiment a little bit and see for ourselves. Let's try that. Let's kind of pick some points. Like for example, I would like to know whether it goes up or down at that point. Now I claim it's going to hug the asymptote. It's going to go up and it's going to get closer and closer to that y equals 3. But maybe I want to convince myself a little bit more of that. So let's try at negative 4 and see what's happening. So I got 3 times negative 4 over negative 4 minus 1. So that would be negative 12 over negative 5, which is 2 2/5. Okay, so I can see at negative 4 is at 2 2/5, so it's really, really close to there. Okay, so what does that tell me? It tells me that's going to go up from here. Okay. Now, we really do have to check a couple of points and just convince ourselves that this is working. Next question is, from after 0, is it going to curve up back again, or is it going to go back down? So I want to pick something between 0 and 1, say a half, and just look and see if that's got a positive or negative value on that. And I can already see what's happening here. Up top I got 3 times a half, that's positive, but a half minus 1 is negative, so I get a negative result. I get something negative when I type that in, which means my graph has got to curve down that direction instead of go back up again. But I didn't know that until I checked to see which direction it was heading. Now, the next thing I'm going to claim is that I know it cannot, I'm going to draw this in here, I know it can't do that. I want you to think, how do I know it can't do that? Well, remember we went and we looked at all the places it crosses the x-axis, and nothing over on that side showed up, which means it's got to be above, it's got to be in this top corner here, has to be. And I'll just kind of pick one spot that we'll test a point on. So let's try 4 again. That seems to be an easy one to work with. So 3 times 4 over 4 minus 1. So I get 12 over 3, which is 4. So at 4, wow, I got dead on there. So at 4, 4, there's a point, and I know in the long run it's going to hug the asymptote So in the long run, it's going to hug the asymptote from the top side, and it's not going to cross the vertical asymptote anywhere, so I know that's the only place it could ever cross. So there's a reasonable picture of what this rational function looks like. All right, so next example, let's start with our X Intercept. So X Intercept, we look at the numerator. Numerator, set that equal to 0. We end up getting 0 out of that. So I know it crosses at the origin. Y-intercept, I'm going to evaluate it at 0. So 3 times 0 over 0 squared minus 4. Well, oddly enough, that also reduces down to 0. So I know it crosses at the origin. Yay. Domain. Okay, so I'm going to look at the denominator. Figure out what's going to make that say 0. So that would be x minus 2 and x plus 2. Okay, so I know I can't have negative 2 and 2. So my domain statement, it's kind of long, but it's going to look like negative infinity out to negative 2 union negative 2 to 2 union 2 to infinity. VAs, so my V, alright, come on now. VAs are the same two numbers that I kicked out of the domain. So x equals 2 and negative 2. Holes, it's not, nothing divides out, so there's no hole. Horizontal asymptote, it is in fact, let's see, top heavy, bottom heavy are same. This is a bottom heavy rational. All bottom heavies have a HA of y equals 0. Point crossing the HA, let's see, so I'm going to say 0 equal to our function, so 3x over x squared minus 4. And I'm going to multiply both sides by x squared minus 4. And I get 0 equals 3x, and I'm right back to where I said earlier. So I know it crosses the HA at 0, 0. Okay. All right, so and then as far as what I'm going to plot first, I'm going to plot any asymptotes, any points, and then I'll look at making a table of values. Okay, so let's go back up to our asymptotes. I know I've got an asymptote at negative 2 and positive 2. So let me kind of draw in those VAs. So I know it's doing this for one of them, and at negative 2 as well. Okay, and I also know that it has an HA of y equals 0. So again, let me kind of connect all those. Okay, and we learned that it's got a y-intercept at the origin, an x-intercept at the origin, and it crosses the HA at 0, 0. So at this point, I don't got a lot of information. Kind of like little like, wow, I really don't know much more, but that's where my my table can come in and sort of help fill in the blanks. Because I know once I figure out which side it's on, I know it's not going to cross the horizontal asymptote because I already figured out the one place it did that at. So let's start over here with negative 6 and evaluate that at negative 6, and I get negative 6 squared minus 4. Okay, now I don't really care what the number is. If I know it's positive or negative, I know which side of the horizontal asymptote it's on, and that's actually reasonably enough, good enough to figure out what the picture looks like. So I know 3 times negative 6 is negative, and negative 6 squared minus 4, well, negative 6 squared is 36, so that's a positive number. So I end up with something that's negative. Okay, so that means my graph has got to hug the asymptotes from the south side. It's on the bottom part of that asymptote. Okay, now, I don't know, so I'll kind of sketch this in. I don't know if it's going to come from the top part or the bottom part in that middle piece. I don't know. But if I pick something like -1, I can see that, and I'm going to go ahead and do it for +1 as well, because I've got the same problem on the other side. And then let's do 6 as well. So again, if we can see positives and negatives. All right, so 3 times -1 over -1 squared minus 4. And again, I just want positives and negatives out of this. So up top, numerator, I get negative, and I actually get a negative, so I end up with a positive result. Okay, so what that says, can I get rid of this without getting too much gone here? That says that the vertical asymptote is positive on this part of the graph. And let's keep going with the 1. So 3 times 1 over 1 squared minus 4. Well, 3 times 1, that's a positive number, and that's a negative, so I get a negative result. So it looks kind of like a snake in the middle, where it's sort of curving both sides. And then if we evaluate it at 6, we get 3 times 6 over 6 squared minus 4. So I get a positive and a positive, which gives me a positive result, which tells me it's got to be hugging above. So on this part of my graph, it's got to be above the horizontal asymptote in that whole hugging idea.